C# also has built-in data types for working with characters and strings. They are the char and string data types, not surprisingly. The character data type, or char, in C# represents a single Unicode character, and that's 16 bits or 2 bytes. So the way you declare it is char, and then the name that you want to give the variable, and you can initialize it if you want to. And it's important in C# to recognize that, unlike languages like JavaScript, when you declare characters, you have to use single quotes, and for strings, you use double quotes. And in JavaScript, you can use either single or double quotes for characters or full strings. It doesn't matter. In C#, it does matter. So for the character data type, use single quotes. For strings, use double quotes. If you're not familiar with Unicode, don't worry too much about it. It's basically an international standard for representing a wide variety of characters from a wide variety of languages, and it supersedes the old ASCII dataset that were used in computers up until just recently. So here we have an example of a character being declared, and this is a lowercase letter a, and as I mentioned, it's 16 bits or 2 bytes, but you're not limited to lowercase letters. You can use things like numbers. You can even use punctuation. All of these are legitimate characters. For strings, you use the string data type, and a string is a series of Unicode characters. And unlike other languages, like say C, or languages based on it like Objective-C, C# provides a native built-in data type for working with strings, and it's just called the string. So to declare a string, you use the string data type, again, the name of the variable that you want, and you can initialize it. And notice here I'm using double quotes to initialize my string, which is part of the C# syntax rules. Strings can also have escape characters in them. In this case, for example, the \n represents a new line character, and these are handled automatically for you by C#. If you make a string that has an escape sequence, which is basically a \, followed by a special character code, such as a T for a tab, or an R for a carriage return, or an N for a new line, C# will simply convert that for you. Now this provides some rather interesting side effects for working with things like directory paths. So for example, if I wanted to make a string that contained a directory path, I'd have to escape out the backslashes by putting a \, in front of them. And this can get a little cumbersome and tiresome to read. So C# provides a special way for telling the compiler, hey, don't worry about escape characters. I just want every character that's in the string to be what it really is. And the way you do that is you put an @ symbol in the front of the string. So in the case of declaring the myDirectory variable, in the first case, I had to escape out the backslashes. In the second case, by putting that little @ symbol in front of the string, I'm telling the compiler, hey, those backslashes aren't escape characters. They're just real backslashes. Please treat them as such. But the fun doesn't stop there. Remember that characters and strings are objects. The character data type is really a system.char object, and the string data type is really a system.string object, which basically means that each one of these data types has some really cool features and methods built in. So for example, if I define a character variable as the lowercase letter a right here, I can do some really cool things on it. I can ask the character, hey, is it an uppercase letter, or is it a digit, or is it a letter? Is it punctuation or white space? I can do things like convert the character to uppercase or to lowercase. The same is true of things like strings. If I declare a variable that holds a string, I can do some really interesting things on it because remember, it's an object, and the objects have built-in methods. So for example, I can do things like convert the string to upper or lowercase. I can search the string to see where a substring appears in the string, and I can do that searching forward or searching backwards. I can take strings and trim whitespace off of them. We already saw how to do things like string.formatting using the console.write line. You can see if a string is null or is empty. And all of these features come built into the language, simply because these data types, even though they're primitives, derive from system.object. One of the things to keep in mind is that strings are what's called immutable. They can't be changed once they are created. Now, you might be saying, well, wait a second, Joe, I've seen you change strings all throughout this course so far. What are you talking about? Well, the thing is that operations that appear to change a string actually create a new string. And the thing is, this can cause a pretty significant performance penalty if you're not careful. So let's take an example. Suppose we had a string variable called result, and we initialize it to be an empty string. And then we have a loop that executes, say, 1,000 times. And then inside that loop, we're saying result plus equals, some strings, some kind of thing that we calculated. Well, even though that plus equals appears to be modifying the string, What's really happening is each time this loop executes, a new string is being created that holds the temporary results of concatenating the string on the end, and then that new string is assigned to the result variable, and then the old string that used to be there is just simply discarded. Now, if you do this a lot in your programs, you're going to hit a pretty significant performance penalty. So if you're doing a whole lot of string manipulation, sometimes it's better to use some of the built-in classes to do this. C# provides one of these called the string builder. So what you do is you would, instead of just declaring a variable named result, you would build a string builder object. In this case, I'm using the string builder class to declare a variable called SB. And then instead of doing the concatenation in the loop like you see there, I would simply use the string builder's append method. And we'll cover objects such as this later on. But the point here is that I'm not just using a straight string to do this. At the end, if I wanted to get the whole result of the string builder as one long string, I would simply call the toString method on it and assign it to a string variable that I've called result. Let's take a look at some examples of using some of the features that we've seen here for characters and strings in real code. So I'm over here in my code, and I've got my chars and strings project open, and I've also got my example snippets open. Over here in the example snippets, you can see that I've scrolled down to the chars and strings sections. So let's go ahead and copy some of this. I'm going to copy these lines right here. Paste those in. So I'm going to save, and don't worry about that little warning that I'm not using the string. We'll get to that in a second. So you can see here that I've declared a variable called mychar, which is a char type, and it's a lowercase letter a. And essentially all I'm doing is exercising some of the methods that the character class provides for me. So I'm going to do a whole bunch of write lines and write out the results of a whole bunch of these methods. Things like isUpper, isDigit, is so on. So it starts off as the lowercase letter a. So let's go ahead and run the code and see what happens. So you can see that the results for these tests are, well, is lowercase letter a upper? No, that's false. It's obviously not a digit. It is a letter. It's not white space or a punctuation. And you can see here the results of calling toUpper and toLower on it. Okay, so let's change it. Let's change it to, say, the number 8. And we'll save and we'll rerun it. Well, in this case, you can see that toUpper and toLower have the same result because there's no such thing as an upper and lowercase 8. But in this case, the isDigit function returned as true. And I'll leave this as an exercise for you to play with. What I'm going to do now, though, is go back to the snippets. And I'm going to copy the string tests. Let's do some of the string tests. So in this case, you can see I've got my string variable. It says this is a message with a new line. And you can see it's got some leading and trailing spaces on the front and back. And we're going to do things like call trim, and toUpper, and toLower, and index of, and last index of. So let's go ahead and save this and run it. And you can see here that this is a string with a message and new line and spaces in it. You can see that the spaces have been cut off. Here, the result of toUpper is that all the letters have been converted to uppercase. Here, they've all been converted to lowercase. And then we found the indexes of the letter A and the substring and. So you can see that even though we've got primitive data types for characters and strings, they're really pretty powerful just, again, because they derive from the base system.object class in C#. And because they're objects, they have a whole bunch of really useful features that just come built in.